Module 1, Refinery Operations, Feedstocks, and Crude Oil Processing. Lecture 1, Introduction to Petroleum Refining. Welcome to the course on petroleum refinery processes. This course provides a deep and structured understanding of the essential techniques, systems, and processes involved in converting crude oil into usable products. Petroleum refining is a complex industrial process that transforms crude oil into valuable products such as gasoline, diesel, jet fuel, lubricants, and petrochemical feedstocks. The process involves several physical and chemical operations, strategically integrated to maximize yield and efficiency. Key objectives: understand the layout and flow of a refinery. Comprehend crude oil chemistry and its impact on refining. Explore major product specifications. Dive into the core processes, distillation, reforming, cracking, etc. Analyze blending, environmental management, and sulfur recovery. Let's begin by understanding how the refinery is organized. Lecture 2, Refinery Flow Sheet and Terminology. A refinery flow sheet or block diagram shows the sequence of units that process crude oil and convert it into finished products. 1. Overall refinery operations. Feedstock reception and storage. Primary processing, distillation. Secondary conversion, cracking, reforming. Treatment and purification. Blending and storage of finished products. 2. Common terminology. Barrels per day, BPD measure of refinery capacity. Cut points, temperature ranges that define fractions in distillation. Yield, percentage of a particular product obtained. API gravity, indicator of crude oil density. Hydrotreating, removal of sulfur, nitrogen, and metals. 3. Storage facilities. Floating roof tanks for crude oil. Fixed roof tanks for refined products. LPG spheres for liquefied gases. Safety, vapor recovery, and fire prevention systems. 4. Interrelationship of processes. Output of one process serves as feedstock for another. Product blending integrates multiple streams. Heat integration and energy optimization across units. Lecture 3, Feedstocks, Crude Oil Chemistry and Classification. Crude oil is not a single compound but a complex mixture of hydrocarbons and impurities. 1. Chemical composition. Paraffins, alkanes straight or branched chains. Naphthenes, cycloalkanes saturated rings. Aromatics, benzene rings, often in heavier fractions. Impurities, sulfur, nitrogen, metals, salts, water. 2. Classification of crude oil. Light versus heavy, based on API gravity. Sweet versus sour, based on sulfur content. Examples: O Brent crude, light and sweet. O Arab heavy, heavy and sour. 3. Properties impacting refining. API gravity determines product yield potential. Sulfur content affects corrosion and hydrogen demand. Metal content can poison catalyst. Asphaltenes affect residue processing. Understanding crude characteristics helps determine the appropriate refining pathway. Lecture 4, Refinery Products and Specifications. Refineries are designed to produce a variety of fuels and specialty products. 1. Major products. Motor fuels, gasoline, diesel, LPG. Heating oils and kerosene. Jet fuel. Lubricating oils. Residue products, asphalt, petroleum coke. Petrochemical feedstocks, naphtha, propylene, butylene. 2. Product specifications. Octane number, gasoline anti-knock performance. Cetane number, diesel ignition quality. Viscosity, flow resistance. Flash point, safety and storage. Sulfur content, environmental compliance. Pour point and cloud point, for cold weather operation. Each specification affects performance, regulation, and market value. Lecture 5, Crude Oil Processing, Desalting and Distillation. The first step in processing crude oil is separation into fractions via distillation. 1. Desalting. Remove salts, water, and suspended solids. Involves mixing with water and applying an electric field. Prevents corrosion and fouling downstream. 2. Atmospheric distillation. Separates crude into fractions based on boiling points. Products: O light ends, LPG. O naphtha. O kerosene. O diesel. O gas oil. O atmospheric residue. 3. Vacuum distillation. Processes residue under reduced pressure to prevent cracking. Produces O light and heavy vacuum gas oil. O vacuum residue for further upgrading. Distillation forms the backbone of refinery operation, feeding units like catalytic crackers and hydrocrackers. Lecture 6: Environmental and Operational Challenges. Refining is energy-intensive and environmentally sensitive. 1. Operational challenges. Equipment fouling. Heat exchanger inefficiencies. Catalyst degradation. Process upsets and unplanned shutdowns. 2. Environmental impact. Air emissions, SOx, NOx, CO2. Water effluents, oily water, phenols, ammonia. Solid waste, spent catalyst, sludge. 3. Pollution control measures. Scrubbers and electrostatic precipitators. Effluent treatment plants. Flare systems and vapor recovery. Module 1 Summary. We have covered refinery layout and process interrelation, crude oil characteristics, major products and specifications, core distillation processes, challenges in operation and environmental protection. In Module 2, we will go deeper into conversion processes, product blending, sulfur recovery, and simulation tools.